Right, in this video, we are going to look over test 3. So question 1, the equilibrium constant, products over reactants. We have 2 in the O2, so I'm looking for O2 squared. We have 2 for the H2O, so I'm looking for H2O squared. And that looks like it will be C, so 1 is C. 2, I have a solid, so I don't want that there. I have 2KNO3, so that should be squared. 2KCl, so that should be squared. And that'll be D. All right, 3. Here we have a Kp. What is delta N? So gases, products minus reactants. 3 minus 2 is 1, so that's B. Determine the value of Kc if given. All right, so we have to write out our equilibrium constant here. So we have K equals O2 to the power of 5. And that's it, right? We have solids. So I'm doing 5 to the power of 5. I'm guessing that might be 125, but let's do that. 5 raised to the power of 5. It's actually 3125, so that is E. So 4 is E. Right? Moving on. 5. Which of the following statements is true? Reaction quotient is the concentration of the product raised to the stoichiometric coefficient divided by the concentration of the reactants raised, measured at any point. That sounds true to me, but let's see the other ones. Reaction quotient is the concentration of reactants divided by, nope, so it's not B. C, reaction quotient is the concentration of the products raised divided by at equilibrium. Nope, that's K. Q. D, reaction quotient is the reactants raised. Nope. E, reaction quotient is the concentration of the products raised to coefficients divided by the point they are equal. Nope. So the true answer is A. All right. In a reaction mixture containing reaction products, E's concentration 1's what's the value of Q? Must be 1. 1 divided by 1 is 1. 7. Which of the following statements is true? If Q is less than K, it means the reverse reaction will form more products. So remember what we're dealing with here. Products divided by reactants. So if Q is less than K, that means Q has too many reactants. So it's not A. If Q is greater than K, that means you have too many products. So the forward, if Q is K, is reaction at equilibrium. Yeah, that's true. So it is C. Le Chatelier's principle, what is that? A chemical system at equilibrium, the system shifts in the direction that maximizes. Nope. System always changes to the pressure changes. Nope. When a chemical system at equilibrium is disturbed, the system shifts in a direction that equals disturbance. No. When a chemical system at equilibrium is disturbed, the system shifts in a direction that minimizes. Yep. So it is D there. All right. Now some questions on Le Chatelier. 9. If FeS2 is removed, what will happen? Nothing, because it's solid. D. Following reaction at equilibrium, what will happen? The volume decreases. Nothing, because you have the same amount of gas on each side. Well, you don't, sorry. Something, yeah, something will happen. I missed the coefficients. So you have 11 gas molecules on the left. You have 8 gas molecules on the right. So volume decreases, go to the side with less gas. So you are going to shift to the right. So that'll be C. 11, it's exothermic. Well, we'll shift it to the left. So it's exothermic. So that means heat is a product. So if I raise the temperature, it'll shift left. Yeah. Adding SO3 will shift left. Yep. Removing O2 will shift left. Yep. So D, all of the above. The Brownson-Lowry model, the transfer of blank in acid base, so that would be protons, E. What is the conjugate acid of HSO3 minus? That'll be H2SO3. That's E. A strong acid electrolyzes, strong electrolyte rather, completely ionizes in solution, D. Which of the following is not a conjugate acid-base pair? That would be A, I can already tell, because they have more than one hydrogen apart. NH4, NH2, they have to be one hydrogen away. Which of the following is true? A neutral solution has water and acid the same concentration. Nope. Neutral solution does not contain any acid or hydroxide. Nope. An acid solution has more acid than hydroxide. Yes. So C. What is the concentration of hydroxide in pure water at 30 of kW? All right, so pure water. So that means H3O plus equals the concentration of OH minus. And remember, Kw equals H3O plus times OH minus concentration. Well, if we're 1.47 times 10 to the minus 14, and if these two things equal each other, I can just say they are x squared. Square root each one. Let's see what this calculation is. 1.47 times 10 to the minus 14. And I'm going to square root that. 1.21 times 10 to the minus 7. That is E. Yeah. 18. Which of the following does not correspond to ionized step of phosphoric acid? So we are looking for D, right? So what's happening here is phosphoric acid is a polyprotic acid. So in every single step, it's interacting with water and acting like an acid. And D, it's not. It's not interacting with water. So that's actually not something that happens to phosphoric acid. 19, calculate the pH of the citric acid solution given these Kas. Remember, if you don't know, well, I give you the acid, but if you don't know the acid, you can just put HA. But since there's three, right, there's three Kas, so there's going to be three acidic hydrogens. And so when you get a polyprotic acid, just ignore the other Ks. Right, so you're going to make this. And we need an ice table. So our acid breaks down. We have no conjugate base, no H0 plus minus X plus X plus X. The X is small approximation is valid. So 0.115 XX. So Ka, which is 7.4 times 10 to the minus 4 is equal to X squared divided by 0.115. I'm getting the X squared because it's my products divided by my reactants. So let us do this math. 7.4 times 10 to the minus 4 times 0.115. I'm going to square root that bad boy. 0.00922 is my X. So that's my acid concentration, 0.00922. Since I want a pH, I do the minus log of that equals minus log of A5. 2.03. So the answer D, 2.04. The answer there is D. Rank the acids in following increasing acid strength. So your strongest acid is going to be the one with the most oxygen. So that's 1. And that's D because only D has 1 being the highest value. Determine which of these ions are neutral. So we need to know our strong acids here. So strong acid, strong acid, strong acid. These three are neutral. So it's just 2. Which of the following will form an acid in solution? That is A, right? Because when NH4 breaks down, so you have NH4 plus and Cl minus, right? So hydrogens positively charged, that's an acid. And that looks to be it. If you have any questions, let me know. Otherwise, study hard, everybody.